Sehr geehrte Damen und Herren, herzlich willkommen an der VIP-Bühne von der Markt und Technik und der Elektronik. Von 15 bis ca. 16:40 wird nun die Elektronik Automotive hier die Automotive Session moderieren. Und ich begrüße auch schon unseren ersten Gast hier auf der Bühne, und zwar Joe Fabbre von Green Hills. So please tell us, what are you demonstrating this year at the Embedded World?
So Green Hills Software is demonstrating our software solutions around the area of functional safety as well as cybersecurity across many different markets, but we have been heavily focused in the automotive space for the last several years. And so we've got demonstrations around autonomous driving, around several safety systems in the car like driver monitoring systems, consolidated instrument clusters and IVI systems and various things like that. We're also, we do more than just automotive, but we are showing medical platforms, industrial safety, and several other areas of our business.
Okay, and what are the biggest challenges in the automotive cybersecurity today?
I would say that the biggest challenges in automotive cybersecurity are really kind of the breadth of the problem. Cybersecurity is a broad term. It means a lot of different things to different people. And one of the things that we're trying to help our clients do is take a holistic approach to cybersecurity. One of the challenges is that there are lots of different solutions for different aspects of the cybersecurity problem. In traditional IT cybersecurity, you might hear about things like, you should install a firewall or an intrusion detection system. And we're starting to see solutions like that show up for the automobile as well. But it's a much broader problem than that. When several of the well-published attacks on cars, thankfully they've all just been research-based attacks. We haven't seen anything really in the wild yet. But when some of those things started to make the news 4 and 5 years ago, we saw the industry reach out to immediately start adopting different cybersecurity policies and trying to put products in place. One of the first things we started seeing was, is the processor, is the ECU that's in the car, is it even doing secure boot? Is it verifying the image? Is it running the software that it's supposed to be running? Yeah. Green Hills has a wholly owned subsidiary called Integrity Security Services. They specialize in this type of system, so everything related to key injection into those ECUs, the digital, the signing of the images and the distribution of those images, firmware over-the-air update systems, and as well as other things like cryptography-related components. They kind of do the whole thing. And that's one aspect. You want to make sure that your ECUs are running the software they're supposed to. But that's just kind of the tip of the iceberg. And so once the ECUs have booted up and they're running the software that they're supposed to run, we transition into something that I call the runtime software domain. And that's where our Integrity real-time operating system comes into play. Integrity's been evaluated to the most rigorous security standard in the world, something called Common Criteria for EAL6+. So that's another enabling component. One of the things that Green Hills does is we work with our customers to, again, take a holistic approach at cybersecurity. So how are you booting the processor securely? Then are you running a secure operating system? But then that's not where it ends. You have to then build a secure software architecture on top of that. There's a lot of analysis. There's penetration testing. There's many different components. And so I think one of the big challenges, I'll keep going back to this, but it's how broad is that problem? And unfortunately, I think what we seeing is we're seeing sometimes is certain parts of the solution are applied, but not the entire solution. And one of the challenges we see is, what is good enough? And I think we've still got a ways to go when it comes to dealing with automotive cybersecurity. There's going to be, generations of ECUs to come that will be deployed in these platforms. And, as an industry, we're the automotive space, it's relatively young when it comes to cybersecurity, and we're going to see that continue to evolve. There will be advanced solutions that will need to be continued to be deployed as well.
And are the automotive OEMs addressing these problems?
Well, that goes back to what I was just saying. I think that parts of the problem are being adequately addressed. What we see now is that many of the OEMs are adopting firmware over-the-air update systems. So when they detect a vulnerability in their software, they can come back to the lab, they can fix it, they can put a solution in place, they can deploy it out to the car. But really, those things are pretty nascent. They're new, and so that's just one aspect. And I'll give you an example. One of the things that keeps me up at night, that bothers me, is I worry about if there's some vulnerability in a car and an attacker finds that vulnerability. It's not just one car that's affected. OEMs make millions of cars every year, and the software is replicated. So the same vulnerabilities get replicated in all of the cars that are out there in the market. And so what keeps us up at night, and what makes me continue to do what I do, is we're trying to solve that problem. We don't want to see an attack that can impact a fleet of cars. And going back to the over-the-air update systems, it's part of the overall strategy. But if there was a 0-day that was discovered in an automotive system, and all of a sudden a fleet of cars gets attacked, it doesn't matter if you update the software the next day or 3 days later or even the next hour after the attack has happened. If somebody gets in and is able to take control of cars, they can crash maybe hundreds of thousands of cars at the same time. And so in my opinion, we need to be developing that safety critical software to the highest levels of rigor, to things like EAL6 Plus on the cybersecurity side for the software, on the safety standards, things like the 178 level A standard. We also work in the automotive space in 26262. ASIL D is kind of the highest level you go to in automotive functional safety. But those critical pieces for internet connected self-driving cars, those we need to first of all isolate the critical components, but then develop them with the highest rigor of any software that's in any system anywhere.
And what is the difference about the traditional IT security and the automotive cybersecurity?
Well, one of the primary differences is in the IT world, if your laptop gets hacked, maybe somebody gets your credit card information, and maybe the bank is insured and you get a new credit card, maybe somebody's able to steal some money or maybe steal some of your personal information, and that can be a real pain, but nobody dies. The difference for automotive cybersecurity is that worst case scenario that I was talking about. If a fleet of cars gets attacked and a bunch of cars crash all at the same time, a lot of people can get hurt. And so we can't rely on things like the traditional IT security approach is that we deploy tons of complex software, it's full of vulnerabilities, but as we find those vulnerabilities, we patch them and then we deploy those patches. And I don't think that's acceptable for automotive software that's really safety critical, because again, it doesn't matter if we deploy the patch even an hour after the attack happens. We need to prevent those types of serious attacks ahead of time. That's the fundamental difference between IT security and automotive cybersecurity, is the safety impact, that those computers are controlling cars that have the ability to hurt people. And so we have to treat that software differently.
And are there any other best practices industries?
Best practices in terms of what?
The cybersecurity or the...
Well, I mean, like I said, it's a very broad problem. So there are many aspects of, and the other thing about a car is it's a system of systems. So it's not just one ECU model, it's a whole bunch of ECUs that are interacting with each other. There's a network architecture in the car. And so the analysis starts with identifying what are the critical pieces in the car, and how do we isolate those critical pieces from the internet connected pieces? Because there will always be large, complex pieces of software that deal with, the LTE modems, with the connection to the back end, with the infotainment system. So, to be able to stream Pandora music or have a nice looking graphical user interface or connect to your cell phone, those are always going to be large, complex pieces of software. And we've got to isolate that software, which will always be used in the car, but we've got to isolate that from the safety critical pieces. And so that's an area where we're working with OEMs and tier ones today, is to look at that architecture, develop the separation model, and then also apply the same type of rigor that we developed and went through with our EAL6 Plus evaluation of our operating system. We want to put those types of programming practices in place. So it includes things like static source code analysis and MISRA runtime checks and all sorts of different components that go into building that software. But we're just really trying to instill that you first isolate the critical components, and then you need to follow a rigorous process and evaluate that software to the level that it deserves.
Okay. So, thanks for your time.
Yeah, thank you. It's nice to talk to you.
That's bye-bye.
Okay.